Checking audio. 1, 2, 3. Seems a little quiet. Move the microphone a little closer. Try again. Got the gain turned up, so it should be fine. Okay, sounds all right to me. Which means we can begin. Ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy. We've been doing a little bit of a mini-series on some beginner programming. I already know I need to redo the series all over again. There's definitely some lectures that need to be broken down, more examples and detail given in several places. But overall, the flow, I think, is pretty good. So, new mini lecture, what even is computer science? Trying a different tone and approach today. I'm just experimenting, playing around, having fun. This is a bit more rambling and, yeah, it's more rambling, less, here's what it is, here's the things, definitions, links, information. This is more, more thinking based, I guess. And that's what we're going to talk about today. So, strap in, and let's get started. All right, we're going to talk about words. We're going to talk about what you think computer science means. We're going to talk about true name magic. We're going to talk about what computer science isn't, and then we'll finally get to the punchline. So like I said, a little bit more rambling sort of lecture today. Good luck us. Words. There isn't a good word for a unit of linguistic meaning. So when I say words for now, I mean a word, a phrase, or a symbol that conveys some meaning. So an individual letter rarely conveys meaning in and of itself, but a word has a dictionary definition. A phrase usually has a combined idea embedded in multiple words, and then a symbol, like the plus sign in that arithmetic, right? It has a meaning, and we all kind of agree on what that is. So talking about words in this context, part of me has this notion that words don't matter. For example, the old phrase, sticks and stones may break my bones, but words can never hurt me, right? So somebody calls you a big meanie or says something mean about you, and that doesn't matter. It's not in the same category as somebody hitting you with rocks, right? They're different categories. They don't really have the same impact. Now, so words are interesting because they obviously can actually hurt people, but in general, there's a far more immediate effect, immediate harm done by sticks and stones than with words. Words can be disregarded, ignored, can be laughed off, can be deflected in ways that sticks and stones cannot. Here's a story I found in a Richard Feynman book, The Pleasure of Finding Things Out. And on one of the early pages, one of the first chapters, he talks about going into the woods with his dad and looking at birds. And the story goes that his dad would say, do you know what that bird's called? And Feynman would say, no, I don't. And his dad would say, well, that's a brown-throated thrush. And in Italian, it's called this. And in Chinese, it's called that. Now that you know what it's called, it doesn't matter. What you call the bird tells you about the people that named it, not about the bird. So let's look at the bird. And they would then look at the bird and try to deduce or reason about the bird itself. So, what kind of beak does it have? What's that beak for? How does it behave? What do you think it eats? What does it hunt? Why do the feathers behave like that? Etc., etc., right? And so he's learned to observe and to reason without necessarily worrying so much about what the words are, what things are called, right? So who cares if it's called a brown-throated thrush? Doesn't matter. What matters is, can you understand what you're looking at? That has had some influence on me. I think that a lot of time in the modern world, we're so worried about using the right word that we forget to look at the meaning, at why we're using that word. What is it trying to convey? Um, what are things called? Doesn't matter. But on the other hand, words really do matter a lot. Okay, so another story from Richard Feynman from Surely You're Joking, Mr. Feynman. Um, I don't have that book on me, but he talks about when he's learning trigonometry. Okay, and he doesn't like the syntax. So again, we're using words to mean symbols, words, and phrases, right? Um, he doesn't like the syntax. He doesn't like the symbols used in trigonometry. So he invents his own trigonometric notation, which is fine. It helps him in his understanding, just like we talked about with the birds. Who cares what notation you're using as long as your understanding is good? But he does run into a problem when he is helping someone else with their trigonometry, or when he has questions about trigonometry, his symbology, the words he's using to describe the problem, aren't the same. And so he can't communicate with another person his understandings or gain understanding from someone else's representation because he doesn't use it, right? And he does standardize in the same syntax, the same words, the same descriptions as everyone else because that's the way things happen. That's the way language works. We all kind of agree on a meaning for things. And if we don't agree, we can't communicate. All right? So while the words themselves don't matter to our understanding, and again, symbols, phrases, words, doesn't matter. The symbols don't matter to our understanding. They do matter in that we have to communicate ideas. So here's an example. We use a lot of jargon uh, in our computer sciencey world, in lots of technical fields, even in non-technical fields. There's a lot of jargon. If you were to walk out onto a cattle ranch, they would use words in contexts that you might not understand all of the connotations of. They would be able to very succinctly describe a situation or a process or a procedure or a thing with words specified to their domain of knowledge, right? Same thing with an electrician or a plumber. Same thing with all sorts of things. Okay, there's very technical jargon specific to that field, and these words are given special meanings because the more narrow your technical field becomes, the more succinctly you need to compress information, the more accurately you have to use your words. Okay, so we invent or add additional layers of meaning to special words called jargon. And that's very helpful. It helps communicate. If I meet someone else from computer science, I know that there are words and phrases I can use and immediately convey a lot of very precise information to the other person. Or if they use a word or a phrase in a very specific way, all of a sudden, boom, I have a lot of context into what that person does and uses for their daily speak, right? So technical jargon is very useful, very great, very wonderful. However, we have this wonderful thing called corporate jargon, where unfortunately the word meanings are instead of used to convey precise, accurate, detailed, nuanced information very succinctly, it's instead designed to obfuscate, to hide, to deflect, or just to make the person sound smarter, right? So let's go ahead and pop into that real quick, just so you can see what I'm talking about. Maybe I did not want to copy it. I wanted to open it. Open. There we go. So somebody in a non-technical field decided that they should also have a wonderful jargon. They should have words that are special to them that nobody else can understand without being in the club, right? And it's not great. It's horrible. Have you read a horrible example of corporate jargon? It's unbelievable. Yeah. So like they take common useful words or phrases and then they use it in ways that don't clarify, don't make things more understandable. Okay? So in this sense, the only thing it's useful for is for showing that you're part of a club. It doesn't convey additional meaning. In fact, it often obfuscates and hides meaning even from someone else in your field of corporate whatever. And unfortunately, that same process of making useless jargon is happening in our fields. Okay, so for example, in computer science, somebody was trying to explain to me the difference between a server and the cloud. And realistically, there's no meaningful distinction between what a cloud is and what a server farm is, right? We already had a word for it, but it sounds new and wonderful and technical if we call it something slightly different. And it's stupid. So unfortunately, this corporate jargonification is also happening, bleeding back in. It bled out of technical fields. Here's a club. The members have very specific, clear, easy to understand ways of speaking using special words. That was taken and said, well, we're using special words to prove we're in a club, but we're not going to make it better or clearer to communicate. And some of that is leaking back out of management into technical fields, and I hate it. Hate it. Oh, this is a great new idea we've invented. Web 3.0. It's still the web. It's still the same thing. Web 2.0 is no different from Web 1.0. They still do the same things. The cloud is no different from a server farm. Doesn't matter. Stop inventing new, less accurate terms to describe the same things that we've already had names for. I don't like it. So there you have it. So yeah, words do matter. They matter a lot. Let's see. For both communication, clarity, and all that stuff, right? If we go to Alice in Wonderland, the second part, Through the Looking Glass, she's talking to Humpty Dumpty. Okay? And he uses a word completely incorrectly. 135 is the page number. Humpty Dumpty says, and only one for birthday presents, there's glory for you. Okay, the word glory in this context means nothing, and so Alice says, I don't know what you mean by glory. Humpty Dumpty smiled contemptuously. Of course you don't, till I tell you. I meant, there's a nice knockdown argument for you. But glory doesn't mean a nice knockdown argument, Alice objected. When I use a word, Humpty Dumpty said in a rather scornful tone, it means just what I choose it to mean, neither more nor less. The question is, said Alice, whether you can make words mean so many different things. Okay, and then they spend the next page after page where every time he uses a word that doesn't fit the sentence, she has to ask what it means. Okay, so he uses the word impenetrability later, and she says, would you tell me, please, said Alice, what that means? Now you talk like a reasonable child, said Humpty Dumpty, looking very much pleased. I meant by impenetrability that you've had enough on that subject, and it would be just as well if you'd mention what you mean to do next, as I suppose you don't mean to stop here all the rest of your life. That's a great deal to make one word mean, Alice said in a thoughtful tone. Okay? So, in other words, if we can't agree on meanings, all we're going to do all day long is sit around and have to keep asking, well, what did you mean by that? What did you mean by that? What did you mean by that? We have to use agreed upon words, or no communication actually occurs, or communication involves largely defining what you said, which may also contain words which we don't have a common usage for, and it just further obfuscates and delays and makes the world complicated, all right? So we can't live like this. This is, Alice in Wonderland is an example of absurdism. It takes something that sometimes happens and blows it out of proportion until it's completely absurd. So Humpty Dumpty, using the word impenetrability to mean something completely different, well, that's corporate jargon for you. What does this phrase mean? What does that phrase mean? Who can keep up with it? They're just making it up as they go, all right? We can't live like that. So here's another example, okay? 2 + 2 = 5. I'm not talking about it in its original context, okay? There's a link, you can follow it. Basically, it was used as a statement of absurdity, all right? It says, if you believe that 2 plus 2 equals 5, you're an idiot. Basically, you're making statements about truth that are not true, and it's evident on the face of it. That was its original context. An example of this is in Star Trek Next Generation, the Chain of Command episodes. Captain Picard is captured and tortured in an effort to make him state the wrong number of lights. So there are 4 lights in the room. He's being tortured and told that there are 5. And over again, he insists that there are only 4 lights. Okay? If you can make someone state an untruth and believe it to be truth, that breaks people. Okay? Orson Welles' 1984, another example. In fact, that's one of the places that this 2 plus 2 equals 5 was popularized, right? Winston, the main character of 1984, ponders on what would happen if the state determined that 2 plus 2 equals 5 was a fact. Okay? And we all know how that ends up. So we can't live with these absurdities. It started off as a statement of absurdity. However, not too long ago, Popular Mechanics, ostensibly science and math related topics, gave some credence to why people think 2 plus 2 equals 5 with that article. Now, I never paid Popular Mechanics, so I don't actually have that article, but it was largely based on this ex post thread by somebody who was making an entirely different point. Okay? And arguably making it poorly. So the X thread was making a point that your statistics can't fully describe a situation, and when you do statistical analysis, when you do a data analysis, you have to be very, very careful not to think that what you've described reflects accurately reality. Okay? However, I would argue he did that badly, and he actually could do a better job explaining his thought process. But that poor description was then put into Popular Mechanics, and people thought that they were super smart by saying, well, you can make 2 plus 2 equal 5 because we agree on definitions. So if we agreed on a different definition, then that would work. And that's just useless, okay? We could agree that the number 2, as written there, actually represents the number 2.5, couldn't we? 2.5. Well, 2.5 plus 2.5 equals 5. Therefore, if we agreed that 2 means 2.5, this would become a true statement. Okay, or we could agree that the number 5, as written there, represents the cardinal value of the set of 4 elements, would be represented with this number 5. Okay, but we haven't. We've already agreed that the number 4 represents the cardinality of a set of things with 4 in it, right? So maybe the word plus is what we need to redefine. The operator, 2 plus 2, doesn't mean to add. It means something else. And this is actually where I think that X thread failed, because when he said, if you take 1 chicken plus 1 chicken, you get 3, because you get a baby chicken. You get a rooster and a chicken, and you add them together, you get a baby chicken. That's 3, right? 1 plus 1 equals 3. What he's doing is overloading the arithmetic operator for addition with a different operator that doesn't mean addition. When you do population manipulations, it is not plus, all right? It is a reproduction thing, not an addition thing. So 1 plus 1 equals 3 chickens, right? Doesn't make sense. You need 1 chicken reproduction operator plus 1 rooster, 1 hen, put into that operator, then yields a 3rd chicken, right? So in other words, he's overloading the plus operator with something completely different, which is where he fails to recognize. He's redefined the plus operator to mean something that's not plus. Okay? So when he's doing those examples, he's failing to note that he's changed the operator. We're not taking 2 chickens in different boxes and putting them in the same box. We're taking 2 chickens and performing a different operation on them, which we happened to use the plus sign for. So if we redefine the plus sign to mean something completely different, sure, then this becomes true. But the point is, if I have to sit down with you every time we communicate and say, the number 2 means this, plus means putting them together in this way, and the number 5 means this, and here's what the symbol equals means. If that's how we have to communicate from now on, completely waste of time. Absolutely useless, because then we have to define another language which concretely defines what these mean, which are not open to interpretation at all. So then we've just done what we've done here. We've already got an unambiguous meaning for this statement, and this is false. If you try to introduce ambiguity to this statement by redefining each of its elements, you have failed to communicate, and you have to have an underlying language with which you can then define what you mean. And that's useless. That's absolute garbage. That's not how communication happens. It'll devolve back into 2 + 2 = 4 being the only true statement available, right? Okay, so a few different thoughts there on word definitions. So back in the day, there was a book called Stranger in a Strange Land written by Robert Heinlein, and he created a word called grok for how Martians see the world, right? An alien culture has a word called grok. And what it boils down to is you have such a deep understanding of a thing that you then have full control over it. Okay? So in computer science, in programming culture, it sort of crept in to where it means, if you say something like, I know Lisp, so this is in the Wikipedia article, you can follow along and read it there. But if you know Lisp, that means, I can program in it, right? But if you grok the language Lisp, that means that you've bought into it, you've used it extensively, you understand the nuances, you understand it inside and outside, you think in Lisp, right? It's different from knowing Lisp. Okay, it's at a whole different level of understanding. And once you grok something, you then have power over it, okay? So we may come back and visit that word a few times throughout the lecture, but here's my question. Well, let's come around to this. Let me give you a small example. Economics is the study of. If you'd asked me years and years and years ago what I think economics is the study of, my naive definition would have been something like this. Economics is the study of money and stuff, right? Not very sophisticated view. Doesn't really communicate what economics is. So if you go look it up on Wikipedia, it's the study of the production, distribution, and consumption of goods and services. Now that's a better definition than what I naively would have written. Okay, it tells you more about it, but honestly, it doesn't really boil it down very well for me. When I finally thought I understood economics was when I read Freakonomics. And in one of the first pages, in one of the first chapters, he defines Freakonomics in a way that helped me understand economics in a much better way. Okay? It's the study of incentives. Now, once I thought about that and understood it, then all of this about production, distribution, and consumption of goods and services, that's kind of tied up in this, right? I have something, you need something, you want something. How do I produce it? How do I get it to you? How do you use it? What do we trade for it? All right. Out of that arises the concept of money. Out of that arises the concept of debt. Out of that arises, the supply and demand curve. Out of incentives arises all of the different pieces of economics that we often talk about. But incentives really boils down everything about economics into a single small definition in a way that deepens your understanding, right? So if we wanted to talk about, market segmentation or Nash equilibria, okay? If I think about those in terms of incentives, they make sense, okay? They fit under this umbrella. So that was when I felt like, now if I ever learn an economic tenant or property or process, that's how I phrase it, is in terms of incentives. And now I understand economics much better than I did when my naive definition was it's money and stuff, right? Okay, so this is kind of what I'm looking for. So I've had the same sort of grok experience using Git and Emacs. I used them, I kind of understood them, and then somebody finally gave me a definition or a description of Git or Emacs that made me light bulb. I understood Git. Now, does that mean I've memorized all of the commands of Git? No, but I know how to search for it now. I know what it means. When it says, oh, we're going to do this, I can see in my head what Git will do. Okay? Same thing with Emacs. You use it, you learn the muscle memory, fine, blah, blah, blah. But until I heard the correct definition of what Emacs is, I didn't get it. All right? So there's like a combination of experience combined with the right definition. Which kind of brings me to, how did I graduate with a computer science degree? And at the time, I couldn't have really told you what computer science is. Well, I had some words I could throw at it, but I didn't really understand it. And it took me a lot of years, largely because I didn't really care, right? For most of my career, I didn't really care what computer science was, but I started to. And how did I get a degree in something and not understand it, not at the level that I should? So what I'm really looking for here is a definition that really captures the essence of computer science. And if you understand that definition and you put in the effort and exposure time, right, that your understanding of computer science will deepen, and you'll be able to then take new pieces of information about computer science and fit it into that definition in a neat, tidy way. Like I need that understanding of it. So that's what we're shooting for today, right? We don't want to get caught in corporate jargon. We don't want to get caught with a bad definition that doesn't really, like, that describes elements of it, right? So like if we go back to economics, right? These describe elements of economics, but don't really capture the heart of economics. This captures the heart of economics, and these elements then arise from that. Production, distribution, consumption of goods and services arises from incentives. So I'm looking for something like that for computer science, okay? So let's go on. Before I move on, though, if you're watching this stream, I'll give you a couple of minutes, all right? I'll mute my mic. We'll wait a couple of minutes. Write down, when you say the word computer science, what do you mean? What are you trying to communicate to someone else when you say the words computer science? When somebody says the words computer science, what do you understand? Okay? Now, if you're on YouTube, send along to me at my email address there with computer science is in the subject. And I'll gather that information. I've talked this idea through with a couple of people, and their responses were interesting. And I would like to expand this lecture in the future with that information. So send it along to me. Do not send it to me after you Google it. Do not send it to me after you finish this video. I want you to write down legitimately what you mean by computer science. What do you think it is? What captures the essence of computer science? And send it to me. I don't care if it's right or wrong. I'm not looking for that. I'm looking for when people use this phrase, what do they mean? And like I said, I've heard disparate definitions. I've heard disparate ideas. And I'm curious to see what you think. So I'm going to pause now. I'm going to mute my mic and give you a couple of minutes to write it down. Write it down on a piece of paper or in a notepad or something. I'll be right back. Oi, Dravest. Welcome to the stream. How's business? Business is good. Good. Getting ready to roll out an update. I finally finished the last feature for release 1.2.2 of my product. Last thing is to fixing some layout issues. There's apparently a difference between Windows 10 and Windows 11 that means that our program doesn't lay out correctly, and I don't like it. So we're going to have to find some way to fix that. But yep. Business is good. We're looking to really do a big push on marketing and producing a second product this year. Getting that word out. In the area where we're working, the the market is very open, but it's very niche, right? So we need to work out that marketing strategy a bit. We're going to probably put some ads in specific magazines, go visit some conferences. And by we, I mean my business partner will go to the conferences and I'll be developing our second product. One thing that a lot of people in that field look at is numbers of product. If they see you've only got one product, they assume that your company's not going to be around for very long. But if you have two products, then they are more likely to buy your first product or your second product because they see that you've been around, you have multiple products, and therefore they believe that there's more longevity in your company for support. So getting a second product would be huge in adoption by the people in that industry. So yeah, come along nicely. How was your week, Vest? How is your web development going? I'm just giving people a few minutes to write down their own special idea of what computer science is. They can throw it in the chat here, or they can email it to me if they're watching the YouTube video later. Okay. I think we've given most people long enough. Yeah, we're trying a more rambly lecture today. We'll see how it goes. So we've talked about words, what do they mean, how do you communicate, etc., etc. The word grok from Heinlein's Stranger in a Strange Land, which is a lame book, by the way. I'm not a big fan of it personally, but the word grok is useful. I actually don't like almost anything Heinlein wrote after his stroke. Most of his young adult stuff from before was excellent. His stuff after the stroke got really weird, and I didn't like it. So anyway. All right, so if you wrote down your own definition, wonderful, send it to me. But then now, this is like a pretty standard learning model, right? You define it, now compare to what other people say, and then I'll give you a definition later. Those 3 steps really help in a learning process. So go ahead and do some searches. What do you think computer programming, computer science, software development, software engineering, what do those mean? And look at those definitions and compare it to what you wrote. I'm just curious what you find there. Because once you have a definition, well, you can do a lot more things with it. It's going good. Today I'll be working on some backend with Django. Yep, Python deadline in about 3 weeks. Okay. I have not done any Django, but if I was going to do, well, I can't say that. I was going to say if I do web development, I like Python better than anything else. But that's mostly because with Python I can get the most bang for my buck, not because it's the best performance. Like, I spend the least amount of time working in Python of any other language, but that doesn't mean that the software developed is high quality. It just means I can get something done and functional. So, cool. Django. Awesome. Okay, so moving on. I'm going to shift gears just a little bit here. True name magic. This kind of goes back to that concept of grok, right? We have a need to name, label, and categorize everything, okay? It's kind of built in. You can find examples of it everywhere, but if we can't name things, if we can't label things and categorize things in a way that other people agree with, we can't communicate with them effectively, all right? Even if they're technically wrong, it's usually better to have some categorization than nothing for communication, for understanding. It's just how our brains work. We put things in little boxes, we slap little labels on them. We kind of have to. And perhaps more importantly, names, right? So computer science is the name, it's the label we've assigned to an entire field of study. We are hardwired for names, right? Specifically, let's take a look at the cocktail party effect. You can go read up on it. But basically, if you're in a very crowded room, all of the conversation will sort of turn into a buzz. You won't really hear individual words much. But if anybody from across the room even quietly says your name, your brain is like hardwired to pick that up. Even though you've completely tuned out everything else, all of the noise, all of the words, all of the chatter, you will pick up your name. All right? It's interesting. It's called the cocktail party effect. And when I say hardwired, I mean you are hardwired. Your brain can't not hear your name. In fact, if your name is common enough or rhymes enough with other things, You'll hear your name when nobody's using your name, just because it's close enough that your brain is like, wait, 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 pay attention. Somebody's calling you. Your name means something very fundamental in your psychology. Okay? So when we're talking about the name of computer science, it's like, well, what is it? Right? We've given it a name, but why? What does it mean? So let's just talk about true name magic, right? In a lot of cultures, you can get your name changed, right? When something happens. So, for example, regnal names. When you become king of England or France, right? It became very, very common to pick a name of a previous royal and just slap a number on there, right? That actually started also with the popes, and as of 533, popes since then have taken a new name when they become the pope, right? So when a significant life change happens, you change your name, right? Not just European culture, Hebrew culture, right? In the Bible, we have several examples of people changing their name, right? And these are meaningful changes, right? It looks to us like maybe a couple letters changed in Abraham and Sarah's names, right? But those are fundamental meaning changes. Their status as a human being had changed. Jacob and Israel, their status had changed. For example, Naomi, that name means, I think, pleasant. Okay? But then tragedy struck, and she changed her name to Mara. She became a different person. Mara means bitter. All right? So she went from pleasant through tragedy to becoming bitter. She was very sad, right? Her life was bitter to her instead of pleasant. Okay? These are meaningful name changes. The meaning of the name reflected how they had changed as a person. Okay? Not just them. Like, let's go to Japan, right? Sengoku Jidai. When Japan was unified, you had three major daimyos, right? And I'm probably saying everything wrong because I don't speak Japanese. I'm sorry, but whatever. But while we talk about Oda Nobunaga and Hideyoshi, I don't know how to say all these Japanese names. Those are the names they ended up with as they went through their life. As events happened, right? You'd win a major battle, you'd unify this little piece of Japan. Boom, they take a new name. So if you actually go read, a book about this period in Japanese, where they haven't done this, their name changes throughout the book, and it's like, I can't keep track of all this. It's hard to keep track of all this, which is why when we Westernize these stories, we just tell the story of Oda Nobunaga and Toyotomi Hideyoshi, right? Because that's the name they ended up with. So we backtrack it through the story and just say that's their name all the way throughout, but that's not what happened. Historically, when they accomplished some great thing, boom, new name, right? So this is like a multicultural thing. It's relatively new to Python. I really like it so far, but yeah, I think I agree with you regarding performance and such. Yeah. Python's cool, but performance sucks. Anyway, so yeah, name changing. So names mean something fundamental to who we are as people. Okay, names are very important to us. Nom de plume, right? Pen names. You know some of these, right? Stephen King, that's not his real name. Mark Twain, not his real name. Stan Lee, not his real name. Dr. Seuss. The list goes on and on and on. Sometimes we want to maintain anonymity, right? And sometimes we change the name because we want our name to look a certain way on the book cover. It actually turns out that a lot of authors with awkward names in English will get a pen name so that their name looks normal on the book cover, right? If I see something with a Polish last name on it, I'm far less likely to pick up that book due to cultural familiarity, right? So they'll take a nom de plume. Or if their name is, another example, Whoopi Goldberg, right? She took a nom de plume, right? Because she thought it would make her more likely to be hired. Interesting. Like I said, the number of nom de plumes out there is huge. We can go all day on it. We're not going to. Nom de guerre. So instead of pen name, these are names of war, right? So if you look at someone like Manfred von Richthofen, sometimes known as the Red Baron, right? One of the most decorated fighter pilots in World War One. The guy was an absolute machine. He was not the best ace pilot, but Sun Tzu would approve of his fighting style. he would only take fights where he had certain advantages. He had a checklist. If he had enough advantages on that checklist, he would go for it. Hey, Dravest. Oh, you subscribed. Thanks, dude. Always appreciate a good subscription. Well, thanks. One of these days I should come up with some kind of reward or something for subscribers, like icon sets or something. I don't know. That seems like work, though. I've got things to do. Okay, so yeah, Red Baron. He would only fight if he had a certain number of advantages on the battlefield before he would engage, and he shot down tons and tons of planes, earning him a nickname from his enemies, the Red Baron. Right. Here's another one, Simo Haya, and that I'm 100% butchering that name. Sniper, probably the number one kill count of any sniper in all of history, right? The guy was an absolute machine. But yeah, he earned the name White Death. Okay, he got in the snow and he just started shooting people. He was actually a beast. His career was finally ended when he got shot by a sniper. It took off his jaw, half of his jaw, and instead of rolling over and passing out, he returned fire, killed the guy, then passed out. Like, the guy was an absolute beast. But yeah, nom de guerre, nom de plume. Sometimes we'll replace our name with something we want to be, or have our name replaced with something that others perceive us as, right? So, like, names are fundamentally embedded inside of us, right? They mean so much. Secret identities, right? Superheroes, right? Spider-Man. Spider-Man did not reveal his secret identity to people. Kept it secret. Why? So that his private life and his professional life would be separated, so that he kept safe the people nearest him, right? Lots of reasons to change your name or to overwrite your name. Lots and lots. Which brings us to true name magic, actually the magic we're talking about itself. I don't know if performance sucks in Python, because maybe that depends on what you use it for. So the parts of Python that are performant were written in C and then given a thin wrapper over the top that is Python. Okay, so all the scientific computing, NumPy, SciPy, pandas, plotting, all of that stuff is basically written in C as a library, and then Python has a thin wrapper over the top of it. If you want performance, you don't write stuff in Python. So Django, maybe the underlying core technologies are fast enough, but if they are, it's because they were written in C, not because they were written in Python, which is kind of how it was designed to be used anyways, right? Hey, El Sai Kangaroo, welcome back. How are you doing? So yeah, that's kind of my opinion on Python. If you want something fast and dirty, Python's great. If you want something performance, write it in C. And if you want a Python on top of that, you can throw Python on top of it. But for the performance part is always written in C. Okay, then I understand what you mean. Yeah. Okay, so we're talking about El Sai Kangaroo. What is computer science? We've talked about words, definitions, meanings, how we name things. And that's kind of where we're at. El Sai Kangaroo, I'm doing all right. Just finishing my first dev vlog for the engine. Nice, nice. I like the presentation format recently. Yeah, it needs work. Like, I'm not a lecturer, I'm not a presenter. So this is me experimenting. Today's more of a rambling lecture, so we'll see how it goes. A little less, boom, boom, boom information. This is more think about names, think about definitions, think about how we talk about things. So we'll see how it works out. Post it on YouTube, see what happens. I've got a few more mini lectures ready to go, so, well, not ready to go, queued up. I have to go make them up, so we'll see how it goes. But if it's something people enjoy, then I'll keep doing it. Yeah, cool. I like the making progress on your engine. Okay, so true name magic. We're talking about Ra and Isis. If you go way back in history, here's a link if you need it. Ra was a very powerful god in Egypt, ancient Egypt, and Isis wanted that power to protect Horus and do her own thing, right? So she crafts out of magic a poisonous snake and puts it in Ra's path. So when Ra's walking by one day, la la la, minding his own business, poisonous snake bites him, and he's poisoned. And he falls down. He's like, "Oh no, help me, Isis! You're the great healer. You can save me." And she says, "Hey, Ra, I can save you, but this is powerful magic. I can only save you if you tell me your true name." All right. He resists, but he's dying, so he eventually does tell her his true name. After which Isis heals him, not using his true name, because that wasn't ever part of it, right? She made the magic snake. She could dispel the magic without it. But what she did was usurp his power, all right? So Ra, he continued to rule for a while. She didn't kill him, but she took his power and did what she felt like. She granted some of it to her son, I think Horus. I don't know. It all gets a little bit fuzzy with all the different mythologies. But she does what she wants, and Ra eventually, essentially retires and moves on from life, right? From being an active part of this godhood thing. And so, kind of what we see here is an example of phishing. She's like, "Oh no, your computer has a virus. Maybe you should type in your username and password so we can help you." All right. This is the first example of phishing. It's, thousands of years before current era, right? The first fishing expedition was a long freaking time ago, right? Um, or the old your hard disk is encrypted. You either pay us money or we'll delete it, right? Or we won't decrypt it. Okay? No, this is a pretty common scam. Oh, you want to keep your hard drive, you want to keep your information and your application safe? You better give us your money or your credit card information or something, right? So we're talking about thousands of years ago. True name magic was very much in line with what we do today, right? Here's how you avoid a phishing scam. Here's how you avoid getting your hard disk encrypted so that it can be held hostage for you, right? Isis was the original, as far as I can tell, at least on this line of mythology, the first fisher, right? Isn't that hilarious? Great. Odysseus, if we want to go a little bit more modern, right? We got the ancient Greeks. They were characters. So Odysseus goes to the Trojan War. They win. Hooray! Good job for the good guys. They beat up Troy, and he's going home on a boat. And they land on an island, and out pops a cyclops named Polyphemus. Polyphemus? I don't know how to say it. I don't speak Greek. And the cyclops picks up two of his men and eats them down in a single bite. Right? Num num num. Nummy Greeks taste good. Goes to sleep. All right. But before he does, Odysseus and him have a little conversation, and Odysseus tells him his name is Nobody, right? My name is Nobody, which is interesting. So Polyphemus thinks this is funny and says, "Well, because you're so funny, I'm going to eat you last." All right, goes to sleep. Well, Odysseus doesn't like this, so he stabs Polyphemus's eye out, which is always good fun, right? We love the modern sensibilities of children's tales here. And Polyphemus, very angry, leaps up and yells to the other Cyclopses, "Hey, somebody stabbed my eye, I can't see." And they're like, "Well, who did it?" And he says, "Nobody did it." Well, his friends think that's hilarious and that he's joking, and they, go back to bed. Well, that's not the end of the story. If Polyphemus had known Odysseus's true name, this wouldn't have happened, right? He would have said, "Oh, Odysseus poked out my eye," and all the other Cyclopses would have been, "Who?" and come running. But when he said Nobody, well, that was a very clever, I'm hiding my name kind of thing, right? You might think that's kind of a funny story. Oh wait, the rest of the story. So as Odysseus gets on his boat and sails away after escaping with sheep, blah blah blah, details. Odysseus yells back, "Oh, by the way, the person who stabbed out your eye is named Odysseus." So after all of that great security, he was paying attention and not doing stupid things and giving away his name to strangers. He goes and gives his name away to a stranger, more importantly, to a stranger who actually wants to get revenge on him, right? Well, that was a mistake, because Polyphemus was Poseidon's son, and Polyphemus at this point says, "Oh, hey, Poseidon, you should really take care of this Odysseus character." And for the whole rest of the trip home, Odysseus has problems with Poseidon. So if he just kept his yap shut and didn't have to brag, he didn't have to have such a hard time getting home. It's his own stupidity. The Greeks love that. The Greeks love it when people's own stupidity come back to bite them. I think there is a typo, but I'll have to go fix that before I make the PDF to attach to the YouTube video. So there you go. If Odysseus had kept his name secret, he would have been fine, but he didn't. So bad on you, Odysseus, for not maintaining proper security measures. Which brings us to LifeLock. You might not be, maybe some of you are too young to remember, but there was a company called LifeLock that was supposed to save you from having your identity stolen. Okay? And the CEO said, I'm so confident in our product that I'm going to put my whole social security number out there. And he put it in the ad. Yeah, and then his identity was stolen over 13 times. Okay? So this is like Odysseus yelling back over his shoulder, oh, by the way, my name is Odysseus, after he completely screwed someone over. This is the same idea, right? You had security in anonymity, and then you gave it up. Okay? More recent examples. Let's go to Germanic folklore, all right? Grimm's fairy tales, always good read. Hilarious. Some of them have been a bit Disneyfied lately, but, you know, Rumpelstiltskin in the original, just what I would expect. Actually, and this brings me to a side mini rant. Even for my mini lecture, I get mini rants, right? Rumpelstiltskin. This is a children's book. Look at that beautiful art. It's all custom painted. It's beautiful, lovely art. Absolutely gorgeous. Why do we assume these days that kids can't appreciate beautiful art? Why do we make kids' books so freaking ugly? It ticks me off. I used to spend hours looking at books like this with beautiful art, looking at the nuance. Oh, look! I mean, look at that! Look at how smug that little guy is. He knows. So let's just talk about the story of Rumpelstiltskin. Blah blah blah. He does things for a princess, and on the third favor, he requires her to promise her firstborn son. Okay, so he does the third favor. She says yes, and a year later she has a baby because she married the prince, because that's how, you know, fairy tales work. And then little Rumpelstiltskin pops up and he says, you know, you owe me the baby. And she cries and whines and whinges, and so he says, okay, fine. If you guess my name, then you can keep the baby. So again, we're back to that whole, do you know the name of the thing bothering you? And so he's pretty happy. She guesses, she fails, doesn't work. I don't know if this is very visible. And she fails. Day 1. Nope, can't get the name. Doesn't matter. Day 2, doesn't get the name. Day 3, one of her servants heard Rumpelstiltskin talking in the woods, and Rumpelstiltskin says his name. He's like, oh, it's wonderful, I'm gonna get a baby, because she doesn't know that my name is Rumpelstiltskin, he says to himself, right? Oh my gosh, what an idiot, right? And she guesses it. So, you know, don't give out your personal, private, true name when nobody's listening, because somebody might be listening, right? And now they have power over you. He lost his prize. More modern stories. The Lies of Locke Lamora. Great book. I loved it. Read it. I did not like book 2 and 3 of the series. I would just leave it at The Lies of Locke Lamora. Excellent book. As part of that, one of the bad guys is a sorcerer who, if he knows your name and writes it down, can mess you up. Okay? The Kingkiller Chronicles. I have my issues with this series. I thought book 1 set up a very interesting premise, a very interesting world. Book 2 did nothing to move it forward, which means everything has to be solved in book 3, and he's not going to finish book 3 ever because there was no progress in book 2. Literally completely dropped the premise promised in the first chapter and never revisits it in any meaningful fashion throughout all of book 2. Very sad, but, you know, it makes use of true name magic. If you learn the name of a thing, you then have power over it, right? Very sad, very sad. I wish people would take their storytelling more seriously, but I really like The Lies of Locke Lamora. Great story. Lots of fun. So if we kind of look at these, we kind of see two different flavors of true names, right? In the case of Polyphemus, if he knew the name of his problem, he could have solved it. If Rumpelstiltskin's princess, the princess in Rumpelstiltskin, she did figure out the name of her problem and therefore solved her problem. Ra did not correctly diagnose his problem. He did not diagnose that it was Isis's magic that was killing him, and so did not need to give up his true name. So instead, he gave up his true name because he didn't know what the problem actually was. We use this today, disease, right? If you get a serious disease, you have to go to the hospital and get diagnosed. They do tests. Until they can put a name to the disease, they cannot treat you, right? You give somebody antibiotics who has cancer, it's not helpful. Actually, it is helpful, but except because your body weakened by the cancer is then therefore weakened and possibly more susceptible to common illnesses. But until you diagnose the disease, you can't treat it, which always raises to me, one of the best words ever is hippopotamonstrous esquipedaliophobia. You know, if a psychologist has to diagnose you for this, it's going to be a real problem because this is the fear of long words. So how do you tell someone with a fear of long words that they have hippopotamonstrous esquipedaliophobia? It's a bit of an ironic name there. They should have picked something smaller. Always a fun ironic piece. But the same thing happens in software bugs, right? When your software is misbehaving as a developer, you have to do the same diagnostic thing, all right? So what's the name of the bug? Maybe the name of the bug is null pointer reference. Is that the full diagnosis? No, we have to know where. So you pull it up in a debugger, and it's like, oh, it's on this file and at this line. Well, have you got the true name of the bug yet? Well, no, because who passed me that null? And now you have to work your way backwards to the source of the null, right? So until you get all the way back, you fully characterize and describe the problem. It's a null pointer reference, which is a fault at this file and this line, and then we backtrack until we figure out where that null came from. Why do we have a null? Then you know what the bug is. You have diagnosed the problem. You have fully described the true name of the bug. Okay? Then you have power over it. Security. If we flip some of these stories around, if Odysseus had kept his name out of Polyphemus' mouth, he would have been fine. Rumpelstiltskin, if he had just not put his password on that yellow sticky note and put it under his desk, he would have been fine. Same thing with Ra. If he just kept his yap shut about what his true name was, he probably would have been fine. Loch Lamora. He did keep his name secret, and therefore he was not a problem. But yeah, you think that might be silly in stories, but username and password, all right? You have a common name. In the old days, you used to have your common name and then your true name, right? Your common name was what everybody would call you. Your password, and then your personal name, your individual name would be kept separately and not used generally. So that was your username, the public part, and then your password, the secret part, right? Same thing right now. If you give out your username and password to someone, you have given them your true name in the context of that username and password, right? Your social security number, your credit card number, all right? These are all parts of this true name magic. If somebody learns these secret parts of you, they then have power over you. Isn't that interesting? Thousands of years ago, right? We're talking about ancient Egypt. They knew about security. Okay? And they knew about diagnosis. Rumpelstiltskin, same story. Ancient Greeks. Almost every culture has stories about names and keeping them secret or discovering the right name so that you can fix your problem. You can't fix a problem if you don't diagnose it, and you can't be safe if you just give out all your personal information to everybody. All right? So as silly as some of the stories sound, they are correct. Okay. Oop, let's see here. So in other words, once you have a thing's true name, once it's identified, characterized, and fully understood, you have power over it. Okay, so this is like that concept of grok we talked about earlier. When you know the name, when you know what something means, you can work with it. You have power over it. You can manipulate it. You can do what you want with it. Okay, because you fully understand it. So that brings us to what is computer science, right? It's a name for a field that honestly is very badly defined. Okay, so let's talk about what it isn't. The first quote I don't like that much, but it's a guy that's pretty famous in computing, so whatever. Computer science is embarrassed by the computer. Whatever, that doesn't really convey much information. I like Dijkstra's better. The computer science is no more about computers than astronomy is about telescopes. Um, so here's another example. A carpenter, we don't call them a hammerer or a sawer, right? We don't name them based on their tool. And in computer science, the computer is just a tool, all right? Before what we think of as the modern computer existed, people did computations with human computers. They were called computers. You would have an engineer, and he would work out the equations and the algorithms for how to solve this very complex problem. And then they would set each piece of the problem in front of a table of computers, and they would hand it to that person, and that person would solve their piece of the computation and then hand it down. Okay? And they actually developed very complex theories of computation before the invention of the computer. Okay? They had redundancy checking, so there would be two tables with rows of people, and at the end, both of those computation answers had better match. Okay? So we had redundancy checking. We had error checking. So somebody would spot check. They would randomly sample a computation and make sure that it was going correctly. These people sitting at the table were just going through rote memorized math steps as defined by someone else. Okay, this other person could be considered the programmer of these people computers, right? Or you wanted to speed up your computations. The thought of pipelining already existed. Here's this piece for you. Here's this piece for you. Here's this piece for you. That computation can be computed once those three are done, but those three can be done in parallel, all right? Parallelization. Breaking the problem down into smaller chunks. If you discovered an error earlier, like they would break down these computations in ways where it was in small pieces, you could pipeline it and say, you start running this computation down, and if we discover an error, we can then just clear all these computations off this table, flush the pipeline, and start over. All of these ideas existed before mechanical computers actually existed. Okay, they used to be human computers. We can build computers technically out of Legos, out of dominoes, out of water, out of mechanical devices. Okay, some of them are very clever, but it's not about the tool. So why did we label ourselves after the tool? Most other fields don't do that, right? So it's not about computers any more than astronomy is about telescopes. Telescopes feature prominently in astronomy. It's a major tool of astronomy, but it's not astronomy itself, right? So in some way, we've kind of shot ourselves in the foot by conflating the tool with the name of this area of study, okay? So I don't like those. Here's some more that definitely agree. The field of computer science is neither the study of computers, nor is it science in the ordinary sense of the word, okay? Agreed, and Harold Abelson and Gerald Sussman have sort of the same take on it. It's not science, it's not computers, or it has somewhat to do with computers, okay? So it's not about computers, it's not science in the normal way. Like, if you want to go look at definitions of science, yeah, it's not really a science. I would even argue it's not really engineering most of the time, right? And we can get into discussion on that if you're interested, but it's not those things. And these people are far more qualified to opine about what computer science isn't than I am. So then that kind of raises the question, what is computer science? I think I've got 3 quotes on this page. Ada Lovelace, before the actual first computer was ever built, she had some great insights into what would become computer science using different wording because we hadn't invented them yet, which she wrote very eloquently, all right? I very much doubt that any of her insights hadn't also occurred to Babbage, who was actually building the machine, but her mastery of her ability to express those ideas was excellent. So in her case, she said it's the separation of objects being operated upon and the objects which are modifying those objects, right? The operations modifying those objects, which kind of agrees with Harold Abelson and Gerald Sussman, right? The authors of Structure and Interpretation of Computer Programming. They kind of compare it with math, which is a good thing to do because there's a lot of overlap between where math and computer science lives. But math is very concerned with, you know, what are your axioms? What are the truths you accept without proof? And then what can we prove is true from there? All right. Most of math is about that. Whereas computation provides a framework for dealing with notions of how. How do I get the answer? And there's some overlap again. In computation, you have to prove that your answers are correct and complete. And in mathematics, you do sometimes have to actually generate a real computation, not just a proof of that you can get the computational answer. So there's a lot of overlap, but computation is much more concerned with process. And if you look at an early book, which is still a great book today, here's the full PDF of the book by Niklas Worth. He literally says programming. So in this case, that's, before we had a term for computer science. Programming is data structures and algorithms. I actually think between these three, that's what we arrive at, right? Data structures and algorithms. That might be one of the best definitions I'd run into in a long time, okay? I almost like this one as is. Computer science is the study of data structures and algorithms, which, if you boil it down, is really just computation, right? Data structures and algorithms define a computation. So we can boil it down to computer science is the study of computation, which means data goes in, you follow a predefined set of steps, answer comes out. You've transformed the input into some output somewhere, right? Using data structures and algorithms. But it's not quite right yet. So we gotta throw one more quote in to really, I think, nail down what computer science is. And that's Donald Knuth. You can't hardly argue with Donald Knuth. He basically wrote the book on computer science, right? He says computer science is largely concerned with an understanding of how low-level details make it possible to achieve high-level goals. That's like the best definition I've ever seen for what computer science is. So if we kind of combine those previous ideas, what we really arrive at is this, and this is my answer. If you've been listening along so far, you kind of understand where I'm getting to here. Computer science is the study of abstraction and computation, or the use of abstraction in computation, okay? And I think this actually describes a lot of the problem of where modern computer science education fails, okay? Is instead of being concerned with low-level details, they've hidden too many low-level details so that a modern computer science student starts halfway up the stack or more. And they don't understand how low-level details make it possible to achieve high-level goals. They are told that it is true, but they know nothing about the low-level details. So when I say computer science, this is what I mean. Computer science is the study of abstraction in computation. And I think that basically boils it down to its most central core tenet. If you go to any computer science topic, it fits neatly inside of this. It is derived from this. You can start from here and discover the need for an operating system and its structure, because you have to understand that. You have to understand why your CPU is architected the way it is because of these principles that you're studying, right? And by architect, I mean as far as the data processes, right? Not the physical processes. We're not engineers who have to know the details all the way down to the activation voltage of a transistor and about the bleed over voltages and traces on a CPU, right? That's beyond where we care about. But we do have to understand the ALU, the decoder, right? We have to understand that programs live in memory on the computer. All of this arises from this definition, okay? You have to understand the algorithms, you have to understand the data structures, you have to understand databases, you have to understand networking in these contexts, okay? So I think this is my punchline. This is it. This is what I arrived at after years of thinking about it. Hopefully that helps somebody. So if you have any questions or comments, let me know, and I'm happy to talk about them. I do have to be out of here by 2 o'clock, so we can't go forever, obviously, although it's been fun. If you want to go back and see anything, I will put up this video on YouTube as usual, and it will be available with the slides as PDF after I fix a typo or two. But overall, I think that wasn't a terrible lecture. I think it has some potential. Like I said, it would be nice to get some data on what people think. I would really like it if I could get this kind of information and tabulate it, right? Before people watch the rest of the video. I want people to tell me what they think computer science is before they get to the punchline. So we'll see how that goes. Yeah, so that's the end of the lecture for now. I'll just leave it here on the punchline for a little bit. Other life things. I am I am working on multiple things. I may purchase a building and put my office down there. I may do. I've got a company I've started with my brother-in-law, and we are kicking that off into full gear this year. That's why I've reduced my streaming to Fridays only. I'm still working on my game. I've actually not got my schedule ironed out enough to make much progress on my game. I need to get that kicked off to Steam here very soon. So there's that. Then I need to start my next game, of which I have so many ideas. So that would be fun. Compilers. I gotta figure out when to fit compilers streaming into the schedule. Or I need to start a compiler series for beginners more than what I've been doing, which is it's just me making a compiler the way I want to, which is not the right way for the general person to do it. I'm exploring different ideas. Yeah. So if there's no questions, I will take off, get this uploaded, and like I said, the slides. Let's see. Actually, I saw. Where was it? Yeah, that probably needs to be a capital O there. Or lowercase, so that's fine too. Yes, that's just an O. There. Why is it not working here? Edit. I've currently fat fingered the delete key. I think this means the visible text, and this means the actual link. Apply. Oh, for Pete's sake. Arg. Fun. Yeah, so this will all be available PDF, so you can follow the links and do your own reading. Otherwise, I think that's the end of the lecture. I think that's the only major typo I had. So yeah, final answer is that. So if you want to quote me, help yourself. All right. If there's nothing else, I'm going to wrap it up there. Like I said, I got a lot of things on my plate, so back to work. And you have a wonderful evening, a wonderful weekend, and I'll see you next Friday with a different topic, different lecture. Maybe we'll do why AI will never replace me, or something like that. Very clickbaity, but closer to the truth. Okay. Have a good one. Bye-bye. Yep, you too, Dravest. Good weekend.